So welcome back to the Lava Academy podcast. I'm your host, Iain MacKinnon, former primary school teacher from Scotland and now living in Reykjavik and playing with lava for a living. And I was going to say I'm on my own this month. I'm not necessarily entirely on my own. I don't have my co-host with me, but we do have two special guests. And they really are quite special. We're talking about a really interesting eruption this time around. So we'll just head over to that interview right now. All right, welcome back, and we are joined today by our special guests. We've got Hólmfríður Sigurðardóttir and Birgir Vilhelm Óskarsson from the Surtsey Research Society. That's quite a mouthful for somebody who doesn't speak Icelandic very well. Welcome to the podcast, both of you.
Thank you.
Thank you.
All right, so we are going to be talking today about Surtsey, and Surtsey is one of these ones that it kind of made the headlines at the time, but it's not something that you hear a lot of people talking about so much anymore, because I think it perhaps has been overshadowed by other eruptions and things that have happened since then. But it really is an incredibly fascinating situation and eruption. So for people who might only have maybe just heard the name or maybe haven't even heard the name, what exactly is Surtsey and what makes it such an extraordinary place?
Yeah, as you rightly mentioned, in Iceland, we are very busy with volcanic eruptions.
Yep.
So when we get excited with one, then suddenly we have to deal with another one, and we forget about the one that we just studied or witnessed. And that is a problem for geologists, because we want to finish our research on one, but then we have to start dealing with another one.
Yeah.
And so I believe Surtsey kind of was a hot topic at one point, but it's still a very interesting place for us Icelanders, and I think it's an interesting volcanic eruption. It's a volcanic eruption that took place in the sea, and we haven't had that many of those here in Iceland recently.
Yeah.
So for those reasons, it was an interesting geological event for us.
Yeah, and it is basically it's just it's a volcanic island, I guess. It's just a chunk of lava that rose up out of the depths. I remember actually I read about it as a child. When I was going through primary school, we had these little reading activities where you would take a card from a box and you would read this passage and answer questions on the passage. I remember reading one about this, volcanic island that rose up out of the sea, and I found it absolutely fascinating. And then I later found out from my father. So my father, he was a geography teacher in a high school, and he was telling me that when they were teaching about volcanoes, that they did a block of study on Surtsey because it was such a unique situation, and was at that point it was relatively recent that it happened as well, and so it was very exciting for him coming to Iceland and going to Vestmannaeyjar and being able to see Surtsey off in the distance. So the fact that it formed within living memory, that's quite an unusual thing for people to be able to do, to be able to kind of witness the birth of a new landform kind of in real time.
Exactly, and it's happening at a similar time as volcanology is growing as a field.
Yeah.
And we had here a very renowned volcanologist, Sigurður Þórarinsson, which was at the time he was a great scientist, a geologist, but he was also a great science communicator.
Yeah,
very charismatic, and he led actually the researches on Surtsey and communicated very precisely with reports and also books for laypersons, and also just through the media what was happening. So I think that played actually an important role in actually advertising what was happening in Surtsey.
Yeah.
And also, Birgir, as you mentioned, the media, because at that time in 1963, the technology of live broadcast television had just started.
Yeah.
So, people were actually seeing live on television at home a volcanic eruption from the sea.
Yeah.
So I think that has had a huge
That's
effect.
true. No, I'd never actually thought about that as being a factor in how kind of publicized it was. But yeah, you're right.
Yeah, we were probably getting the first images of lava flows and explosive eruptions and definitely
and lightnings in the plume and crazy. Okay, it was in black and white, but still.
Still, yeah. And it was quite a long-lasting eruption as well. This is something I didn't quite fully understand. I thought it was a bit more similar to what we've been seeing recently, where it was just a short burst and then done. But it actually went on for quite some time, didn't it?
It's 63, November 14 to 67. So November 14, 63 to 67, so 3.5 years.
And was it erupting constantly?
No. There were breaks, and there was also migration of vents.
Oh, okay.
And that's also an interesting part of this story, that the vents were migrating from one place to another.
Okay, well, that's actually a good lead in there. So can you, if we just kind of backtrack a little bit to kind of the beginning of this whole thing and what was actually happening under the ocean before Surtsey actually broke the surf? What was actually the processes that were going on down there?
In terms of monitoring at that time, it wasn't as advanced as today.
Yeah.
But there were seismometers and there were earthquakes. And people were feeling those earthquakes in Vík and Kirkjubæjarklaustur and Heimaey. And but in November 12, there were tremors, quite intense tremors. And I also read that some people claim to have felt, the smell of sulfur. The waters around that area were a little bit warmer, 2 degrees warmer. Fishermen reported that. And then on the 14th, then we had actually the bubbling and the sea kind of darkened. And that must have been a terrifying, I think, scene to see that.
So when I'm doing the shows here at the Lava Show, I quite often get asked about subsea eruptions and what happens when lava actually hits water like that. So the eruption of Surtsey, what did that look like to begin with, and how did that kind of develop over time?
So it's not really known when it started, but at least on the 12th, there's some indication that there was volcanic activity, under the sea, and which was building an edifice, a seamount to begin with, but then that grew to reach the surface on the 14th. And the first signs was at 7:15 in the morning. So people were already, aware that something was happening. In fissure eruptions in Iceland and point source eruptions, effusive eruptions, which involve, fluid lava reaching the surface. The first phases are usually quite pressurized, where magma is kind of expanding and you get kind of fountaining at the surface.
Yeah, like we've seen on the Reykjanes Peninsula.
Or jets of magma, and that probably what was happening. But then in a subaqueous environment where you have, especially in Surtsey, you have 120 meters of sea on top. that changes the dynamic a little bit of the eruption, because you have water entering the vent constantly. And so we don't really know if the first fusive phase was forming kind of in a pressurized environment, was forming pillow lavas.
Yeah,
that's possible.
So if you've got enough depth of water, the sheer weight of the column of water above is suppressing the eruption to the point where it's not able to kind of react violently with that water and the steam explosions and stuff, and just kind of blobs out on the seabed.
But as then the edifice kind of grows and the water column becomes shallower, then you start getting what we call phreatomagmatic activity, when water enters the vent and interacts explosively with the magma. You have both expansion of volatiles in the magma that is generating fragmentation, but in addition to that, then you have vaporized water, generating additional fragmentation and explosions. And then on top of that, you have quenching, because water is colder.
Yeah.
And that generates an additional fragmentation factor on the particles.
So it's breaking the lava apart through the expanding of the steam
in these steps.
But it's also breaking it by the contraction as it cools. Wow.
Exactly. And that generates very fine ash, which was the problem, for example, in Eyjafjallajökull.
Yeah.
Very fine ash because of the phreatomagmatic activity. And then when you start generating a lot of ash, you continue to build this volcanic edifice with an ash. And Surtsey is a large edifice. It's, I think in terms of volume, it's about 1 cubic kilometer.
Okay.
So that is...
it's quite significant.
It's quite significant in size. Hólmfríður was 1.4 cubic kilometers.
And to put that in context as well, the one that everybody heard about, Eyjafjallajökull, I believe that only emitted about 0.1 cubic kilometers.
Well, I think a little bit more.
A little bit more than that.
Fagradalsfjall is 0.2 probably.
Yeah.
Something like that.
So this is a not insignificant amount of material.
But it was long-lived. So that's also a factor, that it was 3.5 years in the making.
No, you're talking about the size of it there. The size of it today is not what it was once. How much is it actually?
Yeah, so now I was talking about the edifice of Surtsey, but what is actually exposed at the surface is only 0.1 cubic kilometer.
So like an iceberg, there's way more of that under the surface. Yeah.
And if I can just go through maybe the eruption history, and then we can later address the other factors affecting the island, the newly emerged island. But we have this phreatomagmatic phase that builds one crater to begin with, and then there is a migration of the activity towards actually another island called Surtla. It never made it as an island. But then there was another migration towards actually the west of Surtur, which is the first crater, which is today called, and there was another crater formed called Surtungur. We have Surtur and Surtungur.
Baby Surtur.
These are the two craters that make Surtsey Island. And that was also phreatomagmatic to begin with, and created these ash or tuff cones, as we call them. But then Surtungur, that eruption managed to grow above the sea level, and then there was a transition from phreatomagmatic activity to effusive, where lava could just flow on top of the edifice. And
so once it's got
sea.
Above the water, it's not reacting with the water the same, and then the lava just kind of blobs out.
Then we have this transition from phreatomagmatic to magmatic activity, and lava just flowed on top, but into the sea. And as lava flowed into the sea, it started building a delta a lava delta. And that is an interesting formation because we could see that in some of our formations on the mainland, like in tuyas and ridges. These are hyaloclastites, or in Icelandic moberg. We could see these formations in these edifices on the mainland, and there we were suddenly witnessing.
You're seeing it happening.
We're seeing it happening.
Yeah,
and that was, I think, yes, there was already a theory going on how these formations on the mainland had formed, and that they had formed actually in a glacial setting, where you have similar conditions. You have a glacier, but in order for the volcanic for the volcano to get through the glacier, it has to melt.
It has to melt all the ice.
It creates a lot of water, which it interacts with and creates edifices that actually resembled what we saw in Surtsey.
Right. I'd never thought of the parallel between the two things as being so strong, but
a geologist called Guðmundur Kjartason. He had these stapakenning or a tuya theory, which he proposed in 1940s and 50s, and he was able to witness Surtsey. So for him was a big moment. I would say, as a scientist, to be able, to show, I was quite right.
That's right.
Of course, it's not a glacial setting, but it's the same kind of environment with water. And then, after the lava, they built these lava delta. It formed kind of a half shield around Surtungur. But then later there was a migration of that activity towards, in 65, towards another island that I think it's Sirtlingur. And then there was another migration towards another island called Jólnir, Jól, Christmas. It happened actually in December. But then that activity migrated back into the first crater, Surtur.
Right.
And erupted effusively, forming another half shield on the Surtur side. So at the end, you had these two tuff cones of ash, and then these two half shields of lava on the south side of Surtsey. And these half shields, a shield volcano usually that doesn't live up to fulfill its mission of shielding something. But these two half shields, they really fulfilled their mission because they shielded the tuff cones. Because the other smaller
that being
islands,
much sort of softer, much more
it's
easily,
just ash, like the other island, Sirtlingur and Jólnir, and Surtsey, they were just washed in a few months away with the swash.
So it's a bit like, I'm trying to think of a parallel for this. It's a bit like when you, it's a bit like that stuff that you put on the ice cream. And it hardens on the top of it, and the other ice cream kind of melts around the sides, but that kind of holds it all together.
And it's called a lava cap.
Yeah.
And we see that in the tuyas on the mainland, that we have these steep sides, but on top the lava cap.
Yeah.
And we can actually infer the thickness of the glaciers from those lava caps, because that kind of gives you, or at least it gives you the level of the water within a pond in the glaciers. And that gives you a kind of a reference to the thickness of the glacier. That's something that scientists were also looking at.
So seeing this unfolding in this way, I mean, this must have been just gold for the geologists. Just seeing all of this stuff, and like you were saying, seeing people's theories kind of either being proved or disproved, I guess, as well. Could also happen. Probably. For every person who's going, yes, there's probably somebody else going, oh, yes, darn, missed it. So it must have had quite an impact on how we, how we interpret all these kind of deposits that we see in other places now.
The longevity also played a role there, because short eruptions are quite difficult to track and to be present, doing the documentation. But when you have a long-lived event, that gives you more opportunities. And that's actually one of the reasons why we have actually a type of volcanic activity that is ascribed to Surtseyan type volcanism.
Right.
And that is phreatomagmatic activity in shallow water. But there was actually another eruption in the Azores in 58 Capelinos. It was a 13-month eruption, which was also phreatomagmatic and Surtseyan, but it was shorter. And there was a little bit of debate if that
should they be calling it,
if that type of volcanism should actually be called Capellinian and not Surtseyan, because it actually preceded Surtsey. But it was a smaller eruption. It kind of connected to another island. But I think just the detailed documentation of Surtsey played was of key importance there, that it became this archetype in terms of
so a geologically fascinating situation, but not just geologically, because if we kind of sidestep now a little bit, and this is now your domain, is more the biological side of things, because what we have now is we've got this brand new chunk of land that has not been touched by any other processes or even living organisms. It's fresh out of the ground. And now we've got the opportunity to do something that you don't really get much of a chance normally to do, which is to see how life starts moving in. So what did that look like with Surtsey? What were the first things that we actually started seeing appearing there?
Well, when the scientists, they were actually on Surtsey during the eruption, and already in 1964, the scientists saw, seeds of coastal plants and plant debris that had washed on land. From the other islands, or maybe from the mainland of Iceland. And as Birgir was describing, the island was erupting.
It was still actively.
Yeah. And, apart from the scientists, there was other kind of life on the island. And that was astonishing.
People for it to be happening that quickly. The eruption hasn't even ended.
Yes. And then the scientists actually looked at the plants and said, okay, these are coastal plants. And what's so special with coastal plants? Okay, they live close to the sea. And they live in very harsh environments. Now, in the coastal areas where there's a lot of sand, not much water, and the sand is always moving around. And there they were in 1964, just a few months after the eruption started, in late 63. And as Birgir was mentioning, Sigurður Þórarinsson, we had other scientists like Sturla Friðriksson, Eyþór Einarsson, and they actually, they thought this was amazing, and they were good media men, and good by talking to the media and other scientists, and as I mentioned, this was a huge media attraction, and there were lots of scientists that came all over the world to Iceland. So the Icelanders were not alone, thinking about, well, what is happening here? What should it do? And we were we were so fortunate that, the island was conserved or protected from the start.
So it was from the start.
Yeah.
They actually made a decision
in
right away.
64,
that said,
65. Yeah,
it's 65 that it's officially made a reserve, natural reserve.
Mm-hmm.
So what does that
start.
actually entail then? So is it complete ban on anybody actually setting foot on it, or are there certain conditions where yes, you are allowed to? Like, what's the?
Yes, you are allowed to visit as a scientist, and also people from the media, but it is restricted, and it was restricted at that time. So that was very, it was amazing that people at that time saw the importance of this. But of course, we had learned from the eruption in Krakatau in Indonesia in 1927 that where there were lots of visitors, lots of tourists, and that impacts how life successions or colonization is developing. So I am not aware of the talk between the scientists, but the decision was we are going to preserve this island or protect the island.
Actually, for the time, that was a very forward-thinking way of, because the easiest thing in the world would have been for them to, roll up, guys, come and see this brand. But the fact that they didn't do that and they saw the value of what was going on.
Yeah, the scientific value, actually.
Yeah.
And that, the government agreed and said, you're right, this does need to be protected. That's actually quite incredible.
But there must have been a very good communication between the scientists and the politicians. So this wouldn't have happened if people weren't cooperating.
Yeah.
And seeing what that might give us in the future. It's always much easier to look back.
Yeah.
But being able to predict what is important, that is difficult.
Yeah. That's actually, I'm not trying to inflate anybody's egos here, given that I'm speaking to two Icelandic people, but it seems to be something that Iceland does quite well, is this kind of communication between agencies and things like this that are, quite significant. We see with the way that the Met Office is interacting with civil defence and the geologists and all of these kind of agencies.
I think it's easy to see why when your house is shaking daily. You start thinking, why? What's happening? And then you go for the right person. Right? Can you explain to me what's happening? So you contact the experts.
Yeah, and this is a small community.
And it's a small community.
Yeah.
So who is actually then, who's keeping an eye on what's happening in Surtsey at the moment? Like, the biologists presumably are one group and the geologists are another. Are there other kind of groups of scientists or?
Well, you mentioned the Met Office. They are looking at the climate and the weather conditions, because that, like the ocean and the wind, it has impact on life and geological processes.
Yeah, we have this staff from the Natural Science Institute of Iceland that kind of have fixed roles in monitoring both the biology and the geology. For example, myself as a geologist, I go there every second year. And we conduct photogrammetry surveys with drones. So we map the island with imagery and create terrain models and images that then are used by the scientists for their scientific work. So there's this staff, and then there's people from the University of Iceland and other universities that come in with specific research questions, and also visitors from abroad that come in then with specific technology or specific questions that they want to address. But they have to apply for permits to join these expeditions.
Right.
So isn't it, I remember correctly, Birgir, that there are 10 persons that allowed to go in every expedition.
Have you been yourself?
Yeah, well, I was there 30 years ago.
Oh.
And studying soil biology.
Wow.
At Surtsey.
Yeah.
But hopefully I will be able to visit Surtsey soon. As a chairman of the Surtsey Research Association.
Yes. Absolutely. So what's it like when you go there, just from a personal point of view? Because this is obviously this eruption is within Iceland. It's so well known and everything, but very, very, very few people have ever had the chance to actually set foot on it. So what's it like to actually to be there in person?
I think her experience was probably different than mine because the island looked different.
Yeah, yeah.
It was bigger.
It was bigger.
Yeah.
Not as much vegetation as it is now.
Yeah.
Not as many birds, not as many seagulls. I don't think the seals had already occupied the island, but I was thinking about it. I remember one time when I was standing at the coast of Surtsey, and I was looking at Eyjafjallajökull glacier in the far distance on the mainland. And I thought, wow, Fríða, you saw the plume of the volcanic eruption when you were a child. And now you stand here as a scientist.
Yeah.
And you are allowed to do some research on soil biology in this young island.
Yeah.
That was amazing.
Yeah.
And I get goosebumps when I talk about it.
I'm getting them now. Yeah. Wow.
That was amazing. And the weather was so good. And I think you are mostly lucky with the weather.
We have been.
Yeah. At the southernmost island of Iceland, and where the wind blows and the...
Extremely strong at times.
Yeah,
we'll
because
probably come to that at some point.
That's a very valid point, because if you're doing any kind of field work in a place like, I'm an islander myself, maybe not from Iceland, but I know what these little islands off in the middle of the sea, what the weather can be like, and so doing any kind of field work in that, it's got to be problematic sometimes.
Yes, it's tough. It was tough, but the weather was good. So I think we have some force with us that helps us with the situation.
Yeah, in my case, I need good weather for droning. I need at least 6 to 8 hours for finishing this mission or surveys that we conduct, and so I need stable weather.
Wow, stable weather in Iceland.
Yeah, it's not easy. Of course, we have had to do things on different days, because we usually go there for 3 to 4 days. But yeah, it's challenging.
Yeah.
But my experience going to Surtsey, I went there first time 2019, and I had only seen Surtsey from aerial imagery, and everything looks flat on aerial imagery.
Yeah.
There's topography, but it looks flat.
Yeah.
And then when you get there is this mountain. Actually, it's 154 meters high. The crater, the highest point of that island, and steep cliffs. And I was quite surprised actually to see that. It was quite majestic, standing up out of the sea, this island. And another thing that also was impressive was to see that something that I had read in the literature, but just to see an island that we know the age, and that's rare for geology, right? To start with, you know exactly what happened for the formation of all these rocks that you see there, and the age. And you're studying something that is 60 years old, 62 years old now. And but it looks like an old island.
Yeah.
You walk by the beach and the boulders are rounded.
Right.
The craters are cut by deep gullies. And the rock or the tuff cones are hardened into hard rock. And you see these huge cliffs, 90 meters tall. And
so if you were going there not knowing the actual age of
Exactly.
it, you might believe that
You
it was
would
actually significantly
probably
older.
have, assumed it was much older.
Yeah.
So that's one point. And even, and that's something that comes to research that we did recently, we found fossilized boot prints,
Wow.
which are
Sorry?
footprints. And we have written a paper on these boot prints, human footprints.
Okay. This requires explanation.
Exactly,
Tell us
and
about
we'll
this.
probably get into this at some point because it's very exciting. That was a really exciting research because we had to speculate about whom were the persons walking here, that because we could determine the size of the boots and the gait and the stride, and we did.
So what
had
actually happened? Somebody had been walking there at the very early part, maybe at the time the eruption was taking place.
Exactly, and the ash was unconsolidated or still loosened, but it's still the conditions probably were humid because the ash manages to capture the foot. And we were not talking just one or two. We found over 40 prints and 5 tracks. So we're talking about proper tracks with several prints, and all this was documented. And Sveinn Jakobsson, one of the early scientists studying the palagonization, that's probably something we'll discuss as well, the hardening or alteration of the ash into hard rock. He had noticed these prints, but wasn't sure, actually. And then other scientists, Kristján and Lovisa, they had been there and they had noticed these tracks, but weren't sure. So we said, let's do some proper study on this.
Yeah.
And I actually got a geologist that I know, Raúl Esperanti. He's a specialist in dinosaur footprints.
Okay.
To come and document these footprints and use his techniques.
Same techniques, yeah.
That he applies on dinosaurs. To come and do research. And he came in 21 and we published a paper in 23 about this. But he found actually a beautifully preserved footprint. Then he actually, and Þorgerður, which is an artist, they were looking for footprints together and they found a set of really beautiful footprints. And one was so beautifully preserved that you could just see the boot.
Yeah.
The print of the boot, and that substrate must have been a little bit more muddy because you could see the expulsion rims.
Yeah, so it was folded out over the sides. Yeah,
we have 3D models of that, and there is even a monument above Hveragerði with this print. You can go there. You should go there. It's a place where you can see Surtsey from the mainland. It's made by Þorgerður Ólafsdóttir, an artist, and there she has this print.
So was it Nokia or Mendel?
Yes.
Or Scarpa?
No, that's we had all kinds of speculation because we could from these measurements we could tell that we had 3 boots, as we found actually boot prints after 3 persons, one size 46 European size, 142 and 140. And when we started talking about these, people got very interested and they started bringing suggestions of names. Oh, I think this boot belongs to this person or this geologist. Oh, I think this belongs to that one. And of course, we don't know for sure, but we could, from this research, determine that they were laid in between 67 and 70.
Right.
And so in kind of soft substratum, which was humid, but then was covered quickly by sand in a storm for them to be preserved.
Yeah.
And then they were all these package of sediment, it's actually sediment, was then altered together through the process of palagonization, which is the alteration of the ash into hard rock.
Okay, so you've mentioned that exact term there twice now already.
Yes.
and presumably this is something that is happening there in quite a significant way. So can you break that down for us? What actually is that process, and what does it look like? What are you going from to?
Yeah. So in volcanic settings, you have geothermal activity because of the intrusions in the volcanic edifices. But in that sea environment, you have also sea kind of penetrating the edifice and vaporizing, and meteoric water as well, vaporizing, and all that aids in the alteration or leaching of certain ions out of the volcanic glass, because ash is just actually amorphous glass. And especially when it's quenched, it becomes
rapid cooling. Yeah,
it becomes something called sidermyrlon, and that glass type is quite actually vulnerable to alteration, weathering. So the ions leach more readily, and then they precipitate as secondary minerals in the voids in between the glass, and they form zeolites or calcite or clays, and this kind of cements the ash into hard rock.
So the different elements being leached out of the original material, but then reincorporated back into it and changing again
and consolidating.
Yeah. So it kind of locks the whole thing together.
And this was one of the other aha kind of moments in science, because people thought this was a very long process, thousands of years. But in 69, Sveinn Jakobsson, 68, they noticed that there is a kind of a new geothermal area forming kind of centered in the island. And in 69, he's already documenting palagonatized stuff in that area. And then in 7 years, 60% of the tuff cones were already palagonatized.
Wow.
And that is actually what is also preserving the footprints.
Yeah.
And the sediments.
So basically what's left of the island from what had originally formed is stronger now than it was then.
Yes. And these two half shields, they played a role in protecting the tuff cones. But today, palagonatized rock, like we see in the mainland, Moberg, because it's not jointed, it forms kind of these coherent mass of solid rock. It's actually stronger than the lava flows, because lava flows, as it cools, it gets jointed. And joints, they kind of are weaknesses in the lava. So wave loading on the lava flows, they break the joints, and you have the collapse of these big joints, columns from the lava flows. So they are eroding actually quite rapidly, while the hyaloclastides or the tuff cone palagonatized is much more resistant.
Right.
And we see that in Heimaey, for example. In Heimaey, those rocks are palagonatized, and they are quite resistant to coastal erosion.
Okay, wow. This I was not expecting to go off in that direction, but that was pretty fantastic. Yeah. Oh. Okay, so clearly we can see how important it is to the geologists now to have the place to be able to study it, but also from the biologist's point of view as well. We are seeing that place now transformed. You were saying there that it's now got significantly more vegetation on it. So what has actually been able to move in there, and how's it getting there other than the sea itself?
Well, in the start, it was mainly, the seeds, and they were dispersed by the ocean. But 20 years after the eruption in 1985, breeding colonies of seagulls started to develop.
Okay.
And that actually kicked off an explosion in life succession. Because the seagulls, they are, eating life forms in the ocean, and then they fly on land.
And
what's in the guano?
Leaving their mess behind.
Yes.
And so this is a poop-based
yes, you can
explosion of life.
Yes, with amazing ingredient, nitrogen and phosphorus. And they also, the seeds survive going through their guts, and also seeds cling to their feet and to the feathers.
Yeah.
So the plants, they had opportunity to sprout and grow.
Yeah.
And that was actually, and this happened very fast. And this was also an aha moment, because what the scientists or biologists had thought, okay, first the algae and mosses, they will colonize the island, and then they will start forming soil where the vascular plants are going to grow in. But no.
See, that is exactly what I would go to.
Yeah. But as you know, nature doesn't follow a pre-written script.
Yeah.
And Surtsey, or life on Surtsey, skipped that. And the plants, they were able to grow just because the birds were moving nutrients from the sea up to the land.
Yeah.
And that has been going on for 2 decades.
Right.
So that was actually the second wave of life colonization in Surtsey. And we can see in the areas where the seagulls nest, it's a huge impact of them, or impact from them, on the vegetation. But in areas where the seagulls have limited effect,
nothing.
Almost nothing is happening. Yeah, not very much.
In terms of the fertility of the actual island itself, aside from what's being brought in terms of natural fertilizer from the seagulls, how fertile is the soil that exists there?
Well, you need the poop, as you mentioned, or the guano, to actually increase the fertility. And then when you get the vegetation to bloom, then, the soil is starting being formed. And I think it was last year, there was a soil scientist who actually started studying this, and we can see that soil is forming.
Quite mature, actually.
Yeah.
The maturation is quite obvious from certain horizons in the soil profiles.
Yeah. And only since 1985.
Okay.
It's a very when the seagulls started
colonizing.
Yeah.
I'm kind of surprised that they waited as long as 1985 before they kind of moved in.
Oh, I wish I could speak bird language.
Actually, I have one fact here.
But go on.
First seagull landing on Surtsey was December 1st, 1963.
Okay.
And that is
a curious bird.
Yes, that is amazing, because it's in between phretogmatic explosions.
Wow, that bird was taking a chance.
So we had scientists waiting to get in the breaks, and we had the bird.
Wow.
But it's amazing that the bird, if they were kind of in that environment, volcanic environment, looking for opportunities to land.
That's crazy. Wow. So there's lessons to be learned, obviously, from what happened, and in terms of conservation, looking after. Do you think there are other areas maybe within Iceland that really deserve to have the same kind of protection as Surtsey had, or is it especially unique there?
What helps is that it's an island and it's isolated. I would assume that scientists are looking at the succession of vegetation or algae and
lichens and
yeah,
mosses and
lichens
things.
near Fagradalsfjall.
Yeah.
But the area is not protected as it was in Surtsey. So the humans did not interfere in life succession in Surtsey. So that is the main driver
Yeah.
of that we know how life starts colonizing.
Yeah.
And how tremendously, strong life is. It's fragile, but it's also so strong.
Yeah.
And it's so creative.
Uh-huh.
Something is happening that you didn't expect as a human person or a scientist.
So back to the geology part of things, and actually I guess there's crossover into the biology part here as well, because one thing that is impacting the whole world, but Iceland in particular, is the changing climate. Are there insights that we can get about climate change and how that affects the wider world from what we see going on in Surtsey?
If you look at the erosion rates
Mhm.
of Surtsey, Surtsey is in a quite special location at the edge of the Icelandic shelf.
Mhm.
So, as I mentioned, the sea around is 120 meters deep. So
even just a little bit beyond that, it just drops right off.
yes, and that means that it's completely unsheltered by the shelf.
Mhm.
That means that wave energy is extremely high
Yeah.
at that point, which is a little bit different than the coastal areas of Iceland, which where the shelf has kind of eaten that
the shelf
energy.
has knocked the energy level of the
Yes,
waves coming in
exactly.
down a bit. But there in Surtsey, it's literally the first thing
it's
that
just
it's hitting.
getting that energy full force, from the Atlantic current. And we see from just the shape of Surtsey that it has this almost straight cut on the southwestern side, perpendicular to that current.
Okay, yeah.
So Surtsey struggles more than other islands to survive, and it's eroding really quickly. But it had, in terms of erosion, it had two phases: the incipient erosion, where everything was fresh. Those erosion rates were extremely high. For example, in between 67 and 68, they documented erosion of the lava fields amounted to 140 meters in 1 year.
Oof.
Average 75.
Yikes.
That's just because the lava fields, the margins of the lava fields were thin, and the material under them was also unconsolidated.
Yeah.
So that
There's just this loose. As soon as
exactly
the water's able to make any kind of headway into that, it just goes.
It would just disintegrate and break and then erode away. And then these rates, of course, decreased, but they are still high. We still get 5 to 10 years of erosion of the lava fields every year.
Wow.
And so that is a lot of erosion. We're talking about 125,000 cubic meters, which is 4,000 containers of those 6 meters per year of material being eroded from Surtsey.
So at that rate, I mean, how long before it would actually just disappear entirely?
So the prediction is for the lava fields, maybe about 100 years. And then when we have only the palagonatized, tooth cones left, those could probably end longer, a few hundred years. But the lifetime of Surtsey is counted.
Wow. I actually kind of feel a bit sorry for it now. And after all this effort breaking through the surface, I made it! And then all of a sudden...
Then it's gradually consumed by erosion. And then wind erosion is also extremely high. The Meteorological Institute, I think, has documented over 30 days with wind speeds over 20 meters per second. every year. So that is a lot of impact on the tuff cones as well. They are eroding 1 to 2 centimeters a year, so that also counts. And then there are the unconsolidated parts of the tuffs that are also just being washed away gradually. And then on the north side, and that's another interesting thing, that the Atlantic current that hits the island, breaks it, erodes it, and then drags that material along the margins on both sides towards a spit on the north side.
Okay, so you've got the erosion on one side and deposition on the other side.
Yeah, this is a kilometer distance, but you see these huge boulders somehow being transported along the margins and being rounded and grinding and rounded and polished, and then being deposited on that spit on top, on the north of the island. And that spit is actually very dynamic. It's always changing shapes. A storm can actually just change the shape of that spit, and for example transform a boulder spit into a sand beach. If it breaks into unconsolidated tephra, then that tephra is transported quickly into that spit, and then it transforms the beach into a sand beach. So there's a lot of changes in the island just overnight.
But you can imagine how much this weathering impacts the vegetation also and the life forms. But still, it's green parts.
Right. Significant areas are fully
well vegetated. And that's also amazing, and that tells us also, if we look in a broader perspective, that nature has met a lot of destruction because of human activity. And to see that life is able to colonize and grow and develop in a place like Surtsey, in this harsh conditions, that gives you hope that nature can come back in areas that have been polluted.
Something which we've been taken right back to square one.
Yes, and that's why it's so important that we have this long time research going on for 60 years, and research that have been published openly from the start. So everybody interested has been able to learn from what's actually happening there. So, and that is the strength of Surtsey, I would say. Of course, the island itself, even though it's declining, but also that we have this amazing data set for more than 60 years. And without the impact of humans.
Yes, that's the key to the whole thing.
Yes.
Because we just mess everything up. Potentially.
Potentially,
Yeah, we can help, but we can also just ruin everything. Yeah. So if you could, given the fact that it seems that Surtsey's days are fairly limited, really.
Come on.
Yeah. If you could preserve any aspect of Surtsey for research for the next 100 years, what in particular would you want to be able to hang on to?
I actually think more in terms of preserving the data.
Okay.
I think that is also challenging in some ways. But to maintain that story alive. That is also something we have to think about. One is the documentation, but then to preserve that story alive. And I think that is extremely
my whole adult life, I've stuck by this thing of that stories are what makes the world go round. We as human beings, we live for stories. We are stories, and to be able to preserve a story that has such significance, and like you were saying, there's an inspiring kind of core to this story as well, which kind of is
and we have tools mankind has made, and that is protection. And you can say that, as Surtsey is now on the UNESCO list of World Heritage, it is a site important for humankind.
Yeah.
And that helps us maintaining the research and collecting the data as long as we are able to get on the island.
Yeah.
And we see on the small islands in the vicinity of Surtsey that there is vegetation and all kinds of geological processes are going on. So life will thrive on Surtsey.
Yeah. As for the work of the Surtsey Society that you're both a part of, what's still to be done there? What do you kind of see the role of that society being in the years going forward? Is it just preserving that story?
Yeah. Now, as I mentioned, the surveys that we do, we can quantify things much precisely now with these terrain models. We can count things in the volume changes very precisely. So that's interesting in terms of the technology advances, that we have more tools.
Yeah, does not make you sad a little bit that you didn't have that 40, 50 years ago? That we could actually have...
We do have images from the very beginning, and we are using those images to create terrain models with the same processing techniques that we use. So we actually have terrain models from the first stages as well. Yeah. Of course, not in the same resolution.
No.
But still good enough.
But you got something,
for these, for the quantification. But there are several other projects there. We have friends from the Speleological Society that are mapping caves in Surtsey. And they've done a terrific job now mapping the caves, and we try to connect these they actually scans that they made with our 3D models. And we actually published 3D models on our webpage and of the Natural Science Institute of Iceland, and also on Sketchfab, so people can have access to Surtsey in one way.
You could 3D print Surtsey.
You could, yeah. But they have been mapping caves, and one interesting thing that they've done recently is map caves within the Surtungur crater. So we are kind of getting access to a plumbing system within a crater. And that is, in Fagraðarfjall, we were thinking about the plumbing system within those craters. And in Surtsey, we have access to it. And I've gone into some of these caves, and there are tubes, and you walk through these tubes, and it's fascinating to have that experience, to see that. But and with erosion, one good thing about erosion is it kind of opens new cross sections into the island. So you start seeing things that you were speculating first about, and then you see a cross section of it. Yeah. And for example, there are caves that are coming to light through the new openings. Then there are the geophysicists. They do all kinds of measurements, GPS and leveling measurements, and there was a paper that came out recently that showed that the island has subsided about 1 meter. This is forming. That's just due to compaction and also polygonization of the material. And then there are people studying or measuring the temperature of the vents. We have fumarolic vents, and they are still very hot. We're still documenting 100 degrees, 90 degrees within cracks. Before the temperature of the cones was more evenly distributed, but now it's more focused into these cracks. Yeah. And they're still migrating. So some of these cracks, they close and then they migrate to other places. Yeah. But still very high temperatures. And then there was a sustained project where they, in 2017, where they drilled 3 new holes into Surtsey, and they were studying palagonization, and they could actually compare a hole that was drilled in 78 with then a parallel hole in 2017, and they could see how the ash or the tephra in those holes has actually matured in terms of palagonization. And they also actually drilled a little bit into the central parts of the vent, I think 300 meters, and kind of into the the central areas of a diatreme, which is kind of that carrot-shaped vent that extends actually way below sea level, or the sea floor. Actually, it goes way down into the sea floor, several hundred meters, and they could describe a little bit that environment, because where the fragmentation starts is way actually below the sea floor when the eruption is starting. Yeah. So that sheds a little bit an insight into those initial stages and the follow-up of the eruption as it was growing. But in the palagonization world, there's still some uncertainty what the heat source is actually. If it's the heat of the pile itself, reminiscence of the heat of the residual heat, or if it's the intrusion. We suspect the intrusions play a key role, but they haven't found the intrusions. And that was another project that they, with the drilling, was to try to go through these intrusions. They haven't managed to find them. So they're somewhere, but even with gravity measurements, they haven't been able to find them. But there is a rumor that palagonization even continues in the boxes of the cores in ambient temperature. So that could indicate that there might be even some other process like exothermic or microbial affecting the palagonization. So so there are ongoing studies related to that.
So it's certainly not a closed book.
Exactly.
There's a lot of stuff still to be found and worked on.
So the island itself is living.
It is living.
It is. It is. And it's so it's so strange when you think of what is at its most basic level, it's just a lump of rock that's appeared in the sea, but it's giving us so much insight into so many different things.
Yeah, important for the Icelandic geology, because we have many things here that, everything we see in Surtsey, we see also on the mainland, so it's helping us. But also for a broader international community, the things we see here are also seen in other places. Japan, Hawaii, Antarctica, British Columbia, we have haloclastites or tuffs, palagonized tuffs, or we have cones, shoot cones, and so all these is applicable. This is information that can be used in many places.
But biologically, it is actually that it is protected so that the human impact is not happening there. You don't find many places on Earth
that's the thing.
Where that's the case. And cooperation in the scientific community and dissemination of knowledge scientifically, but also for the general public is important to understand the value of this amazing island.
Yeah, well, thank you for bringing your insights to us and for helping us now to get it out, hopefully, to a few more people.
Thank you for doing that.
So, Birgir and Hólmfríður, takk kærlega fyrir komuna.
Verði þér að góðu. Takk.
So another phenomenal interview there this month. big thanks to Hólmfríður and to Birgir for coming in. And Birgir did mention during the interview that there are, some interesting documents and things that people might want to have a look at. So if you do, check out the show notes. In those show notes, we're going to have links to some of the things that he was mentioning and even some stuff that he was talking to me about off mic. So if you want to find out more about Surtsey and what's been going on there and what's actually still going on there, do check out some of that stuff. And also, if you want to get in touch with us here at the podcast, if you just email us at podcast@lavashow.com, that will get to us. And be sure to kind of share the love. If you know anybody who might be interested in hearing more about lava, then send them our way, and make sure that you also subscribe to the podcast on your podcast catching platform of choice, or on YouTube, of course, as well. But anyway, that's it for this episode. We hope to see you again next time. Bye for now.